Alrighty, so we are going to talk about the distance formula, and to start off with that, we are going to plot some points. So we have 3 points we're going to plot. We're going to make sure we include some letters to indicate what they are. So our first point is point A, and that is at 0, 3, which means I go over 0 and up 3, and I call that point A. Next, I have a point at 9, 7, so I go over 9, up 7, and label that point B. And lastly, I have a point C at 9, 3, so I'm going to go down to 9, 3 and call that C. And I'm going to connect those lines. Now when I look at this shape that I've created, I can see that I've made a right triangle. My right angle is right here at angle C. And on your paper, it's going to ask about some things we notice about the length of these lines. Well, I can figure out the length of line AC, AC by counting. I can start at A and go 1, 2, 3, 4, 5, 6, 7, 8, 9, which means that AC is 9 units long. I can do the same thing for B to C. Start at B, go down 1, 2, 3, 4, and so I find BC equals 4 units. Okay, but I don't know how long. I can't do that same thing for A to B. A to B, well, I could count to the side, except for I'm also moving up every time I'm moving to the side, so my movements are not in one direction, they're in 2 directions. Now, because I know this is a right triangle, I know that this is called my hypotenuse. And so if I'm missing a side of a triangle, and I have 2 sides, side 9 and 4, I can find the last side using our Pythagorean theorem. Okay, our Pythagorean theorem is what says a squared plus b squared equals c squared. But it only works on right triangles, and we're going to run into some instances where we want to find the length of a line on a graph that is not the side of a right triangle. And so we're going to use our Pythagorean theorem. Our Pythagorean theorem worked to help us find the length of any line on a coordinate plane. So what we use is called the distance formula, and the distance formula comes from the Pythagorean theorem. So we used our a squared plus b squared equals c squared. It helps us to find the length of any line. It does not have to be on a right triangle, on a coordinate grid, meaning x, something that looks like this with an x and a y-axis, that's our coordinate grid. Okay? The distance formula. The letter D stands for the distance. Is equal to the square root of y2 minus y1 squared plus x2 minus x1. Oops. Let me erase that. X subscript 1, where x1 comma y1 is a point, and x2 comma y2 is a point. So those x2s and y2s and x1 and y1, those just indicate those are points. x1, y1 is a point, or we could call it point 1, the x value of and the y value of point 1. And the same thing goes for y2 and y1. And x1, y1 is a point, x2, y2 is a point. Okay. And what's really nice is because we're adding between these two sets of numbers, the y's and the x's, as long as the y's are grouped and the x's are grouped, order doesn't matter. So you'll see we're going to flip some things around as we go. Okay. So let's do an example. The first thing I'm going to do is write out my distance formula. Okay? My distance formula says that the distance between 2 points is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. Okay, now that I have that, I'm going to identify what is my x1, what is my y1, what is my x2, what is my y2. So I'm going to choose a point to be point 1. And what's nice is it doesn't matter which point I choose to be point 1. So I'm going to choose 7, 2. I just chose the second point to be point 2 or point 1. Okay? So then I'm going to identify the x value and call that x of 1. Well, the x value is 7. So y1 is equal to 2. The y value of point 1 is 2. So anywhere I see an x1, I'm going to replace it with a 7. Anywhere I see an y1, I'm going to replace it with a 2. And I'm going to do the same thing for point 2. Point 2 is 1, 5. So x2 is equal to 1. y2 is equal to 5. That's the y value of point 2, the x value of point 2. So now I'm going to write my distance formula, but instead of using x1 and y1, I'm going to actually plug in those values. Okay, so I'm going to plug in a 5 where I see y2. I'm going to plug in 2 where I see y1, because 2 is the y1 value. Same thing goes for x's. x2 is 1 minus x1 is 7. And I'm going to square it. And then I just solve from here. So my first step in solving is simplifying what's in the parentheses. Well, 5 minus 2 is 3. 1 minus 7 is negative 6. Next, I'm going to square those terms. So I get 9 plus, okay, negative 6 squared. That's the same as saying negative 6 times negative 6. Well, negative times a negative is a positive, so I'm going to end up with positive 36, which is equal to, when I add them together, the square root of 45. And so I get approximately, let me grab my calculator here, because I don't know how to get that exact. And we are going to take the square root of 45, which is 6.7. 6.7, and because it's a length, we're going to write units. That's what tells us it is a length value. So that is the distance between those 2 points. All right, we're going to do the process again for another one. Make sure you're listening along. If you hand me a piece of paper that has the word turtle on it, I will know that you listened and give you some candy. All right, we're going to start by writing out our distance formula. Distance is equal y2 minus y1 squared plus x2 minus x1 squared. I'm going to have my point 1. This time I'm just going to have it be the first one they give us, negative 7, negative 2. So x1 equals negative 7, y1 equals negative 2. Identifying the x and y value of the point. Next I'm going to take point 2, which is 6 and 9. If you are able to identify your x1 and y1 without writing out this step, you are more than welcome to do that. But this can be a helpful step in keeping it all organized. Okay. So now I'm going to plug in my values into my equation. So I get 9 minus, my y value is -2, squared plus 6 minus a -7. So we get to work with our negatives today. 9 minus -2. Well, minus a negative is the same as adding. So 9 minus -2 is 11 squared. 6 minus a -7, or getting rid of negativeness, makes things more positive. So I get 13 squared. 11 squared, I can do that in my calculator as 11 times 11, which is 121. 13 squared is 169. Add them together. I'm going to use my calculator quick. So I get 121 plus 169, which is equal to 290. And I take the square root of that value, and I get 17.03 units. So that is the distance between those 2 points on a coordinate grid. You will notice if we get a decimal, that means that we were not able to equally count out. It might be that we're cutting through enough pieces that we're getting a decimal of a length. Okay, so we're going to be comfortable with decimals in our answers today. Okay. The last one is available for you to do as an example on your own. What I would like you to try is to try doing it with our order switched. So we said order doesn't matter, so we're going to use the distance is equal to, and instead of putting our y's first, we're going to put our x's first, and instead of putting our x2's first, we're going to put our x1's first. And because my x's are together and my y's are together, this will still work. So I want you to pause the video, solve this one out, and then come back, and I will, and you can check your work. So I'm identifying point 1 to be 10, 0. Point 2 is going to be 0, 4. I'm not going to, or here's my identification of the pieces. Y2 equals 4. Okay. So now I'm going to plug those values into my equation. So my x1 is 10 minus my y, or x2, which is 0, squared plus my y1 is 0, minus my y2, which is 4, and then I simplify. 10 minus 0 is 10, so 10 squared, plus 0 minus 4 is -4 squared. 10 times 10 is 100. -4 squared is going to be positive 16. So I get the square root of 116. I do that in my calculator. And I get that the distance is approximately 10.7 units. You can flip around your things in all kinds of different orders as long as your x's stay the same and your y's stay the same. It is all good, and you should get the same answer for it.